Hi everyone, happy to see you here on Beetroot Academy Global channel. Today, we're excited to meet you at our Green Coding webinar, which is actually about the responsibility that tech companies and everyone who is involved can make something to make coding green and sustainable. I'm Varvara, and today I will be moderating this webinar. And I'm happy to introduce you our speaker, Janne, hello, who is actually in coding since 1983, if I'm not mistaken, which is actually 7 years before I've been born even. So you had plenty of time to... What's wrong with the stream? I guess, or not. I'm not sure if I don't have any troubles with my connection. So I will be really grateful if you will tell us about that, if you can hear me. I apologize for this. Have never met these troubles before. Oh, yes. Okay. We can move on. My apologies. So I'll just pass my words to Janne. The stage is yours. You can start. Welcome.
Thanks. And I must say that in 39 years that I've been coding, I'm used to that there's a problems, that this is out of a problems, the whole coding stuff. Hopefully you can see my screen now. So I'll go to the topic. So my name is Janne Kalliola. I'm the founder and Chief Growth Officer of Exove, and today I'm going to talk to you briefly about me, my company, and my book. This is not the most important thing, even if I sometimes like to think like that. Then let's go to discuss why is this important in the first place. Where do we generate emissions? How the energy is consumed in modern software? Some words about measuring waste and minimization, some practical solutions, and then final words, then question and answer at the end. So I'm been coding from 83, started with Commodore VIC 20, got that as a Christmas present, so soon it will be 40 years. And I have coded in a number of different languages. Now I'm focused in the growth of Exove, a Finnish and Estonian-based digital agency. And then I've been working with green coding and carbon neutral for a few years. I'm the chairman of board of Code for Finland Association, and we have released a carbon neutral software company label. And then if you want to follow me in LinkedIn or get in touch in LinkedIn, then that is URL. But let's go further. Exove, the company, we are around 85 people right now in 4 offices, and we focus on creating digital solutions that fight against digital frustration, as there was a prime example of Zoom and YouTube connection there, that sometimes the systems frustrate people a bit. So we try to make easy to use systems that are also green. We do training, consulting, architecture, coaching, and audits. If you are interested in getting help with the green journey, then we are here. But let's get to the actual green stuff. So I wrote a book 1 year ago, approximately. Then 1 year ago, I released the Finnish version that is on the left. And then in January this year, I released also the English version. And then in September this year, I released the second edition of the book that now goes with talks about the AI, cryptocurrencies, crypto contracts, Internet of Things, data, testing, and a few others. 130 pages, pretty easy to read what I've been told. Available for free from exove.com website. And there will be, at the end, there will be also a QR code that you can use to download the book. But to the topic. So why is this important? The Finnish Ministry of Transport and Communication has created the first climate and environmental strategy for a state in the world a couple of years ago. In that document, there was mentioned finding from the research that the ICT sector accounts anything in between 4 to 10% of world's energy consumption. It is quite big sort of fork, so to speak, that it's quite far between, because it's very hard to estimate the real numbers. And then Lancaster University made a study 1 or 2 years ago that the industry creates 2 to 4% of the greenhouse emissions, and these numbers are growing. So we emit more emissions, for example, than airlines. We are thought that we are the good guys, and then the airlines are the bad guys. If you take the average of the emissions, that is 3%, and then we take the total emissions, global emissions from the UN emission gap report from 2022, that was 58 gigatons. Gigaton is a unit that is like 9 zeros, and then the tons and 12 zeros if you think about it, kilograms. So it's around 1.6 billion tons of carbon dioxide every single year. And because these numbers are pretty big, then to give a perspective, it's around the mass of all land mammals and people. So every single year, that amount of carbon dioxide is emitted to the atmosphere because of ICT, and the numbers are growing. So where that actually happens, so we can split this in number of different ways, and this is the way that I'm used to, sort of from the work perspective. There's the developer work, that you go and you develop stuff, you sit in front of a computer, and if you sort of remove all the bells and whistles, this is very typical office work. And then the commuting, office heating, cooling, business travel, and so forth are the biggest sources of emissions, not the actual work. Then the testing and deployment, build automation, and so forth might be bigger, especially if you are targeting it to a number of different platforms. There might be extensive amount of tests that are run for every commit, and then there might be builds that happen in a number of different platforms. It might be also smaller, but it's most probably bigger compared to developer work. And then there's software usage, that is the energy used by the software and data transmission when people use it. And then this typically is where the amount of users, the amount of equipment, the amount of data transfer grow really big. So the things on the left, they matter somewhat. And of course, if you can, instead of driving to work, you can bike to work or you can walk to work, then all the better for the environment. But the focus needs to be on the ride, on the software usage, both at how much the software is used and how efficient the software is. Unfortunately, the earning logic in our industry is based on bringing new solution features to the market. It might be time to market for SaaS services and software consulting like I do. Then the clients typically look at the time and price spent, at how much, how long, and how much. And the developers, we think mostly about making our own life easier. The efficiency and any environmental impacts are not discussed because it's somebody else's problem, it's somebody else's budget. And we need to extend the environmental responsibility, but there has been little progress so far. Finland is doing great with the getting people to understand the problem and research. I think that I could sort of say that we are leading currently, but this doesn't mean that every Finnish software would be green. Far from it, actually. And then the other countries, there is less interest in these topics. It depends on the sort of both the culture and the economical environment. For example, in Europe, there's more incentives and also stick and carrot kind of thing with the making things green. But then when you go to States or the UK, less so. So then it's about the individuals and their wishes. So the energy consumption in modern software, that is the sort of the key to understand that where you are in the picture, you can be also all over the place in the picture, and then what you can do about it. So almost any software that is built nowadays has three separate components. There are the end user devices where users use the service. Then there's the network that connects the end user devices with cloud or data center where the centralized part of the system resides. This is true for mobile applications, this is true for the websites, and this is true for the desktop applications. I'm using so old version of Excel in my Mac that the help stopped working because Microsoft shut down the web part that was required for the help. I thought that I have a full complete set of the program. The Excel still works, but the help doesn't. But no, it had some parts in the cloud, even if it's considered as a standalone desktop app. The devices on the user side might be battery powered or they are plugged in the wall, and this has consequences on the energy consumption. And then how much the energy is consumed by the device should be split between different applications running on the device. So if you have a mobile app, then how much that mobile app consumes electricity from the mobile phone, or you have a desktop app, how much consumes there, among other processes, because the other processes will be there will be always a baseline cost, baseline energy consumption that when the system is on, it consumes some energy, does all kind of things. So how you will split the energy consumption, and then if you think that you are doing a desktop app, how much of the window manager's energy consumption is due to your app. Then there's the data network. This is sort of easy because there's a pretty good coefficient available for the different connection methods, and the last mile typically specifies most of the connection energy use, and that is controlled by the end user. So you as a backend developer, for example, you have no way to force the user to use some connection, but they will use something. And you could also, of course, adapt to the situation. That if the user comes with mobile, then you would use a bit different tactics to, for example, how much data is downloaded to the app. And then the cloud or data center, where all the systems that are participating in providing the service need to be counted in. Different kind of web and application servers, databases, storage servers, storage systems, firewalls, VPN endpoints, log systems, backup and restore, internal connectivity, all the cloud functions that they're using. And then you should somehow calculate the energy that is consumed by the dedicated systems and then the shared systems that your platform or your software is using. the energy is consumed on the device side, so that there are the physical. It's sort of because the device is very, very sort of one single device per one single user typically. It's sort of one piece of equipment that it has CPU, GPU, display, network connection, GPS, and whatnot. And when it's battery powered, then typically very optimized hardware, because nobody would like to run out of juice during a working day. But then if it's plugged in the wall, then it's a completely different thing. For example, televisions. Nobody typically knows what is the consumption of energy of their television set, because people don't care. The electricity is free, and there's typically normal situation, unlike in some parts of Ukraine, that there's a sort of war going on there, then that might affect when the electricity is available. But when you go to sort of like the normalcy, then typically in developed world, the electricity is always available, and it's surprisingly cheap or inexpensive compared to the developer work. But the screen is the biggest hog of energy in mobile devices. So if you could make your system so that the screen doesn't need to be on, then you would save energy, and quite much actually. Then the network side is the electric consumption of the data transferred, and typically that is calculated energy used by gigabyte, and it varies a lot. There might be, if we take a 4G network, then that's like 10,000 times less efficient compared to optic fiber. And typically the trunk network is optic fiber all the way. So then it means that the last mile between you as a user and the first network connection from your point of view, that connection, if it's Wi-Fi, if it's 4G, if it's wired connection in office, that's typically where most of the energy is consumed. And then the server side, very optimized hardware that is designed to be run full throttle all the time. And if you can pack those devices as full as possible, you would avoid need for new devices. And that is one of the reasons why typically cloud is more energy efficient than having your own data centers, because there is less waste in the servers that are just waiting for work. Software needs hardware to run, and then also the data transmission needs hardware, and the hardware causes emission in several steps in its life cycle. The hardware needs to be manufactured. That's typically the bulk of the emissions. Then there's logistics, and the hardware is built in China or in Taiwan, and then the different parts come from different parts of the world, and then it's sort of put together and then shipped away. Again, logistics. It might go to company's headquarters, then it's configured and then sent to the individual people. And then there's the usage. That's mostly the energy, electricity used, and then dismantling that can reduce emissions if it's recycled properly. But only 17% of the electronic waste is recycled properly worldwide. Finland is pretty good. We are currently recycling 42%, but there's a lot of electronic waste that is not treated properly, ends in the landfills, ends in the riverbeds in Africa, and so forth. And the funny thing, not funny and funny, but the interesting thing is that if you have a consumer grade device, a laptop, a mobile phone, a television, and when you buy it, then typically 80 to 85% of the emissions have already happened. So try to keep your current systems functional as long as possible, because that will save huge amount of emissions if everybody would do it. So don't change your phone every year, every 2 years, every 3 years. Try to squeeze the last miles out of it. And then all energy production causes emission, including also renewable, because the windmills doesn't sprout up from the ground, but they need to be manufactured, they need to be moved to the location and so forth. And then there's a very big differences between countries. The Nordic countries where I'm living are blessed with very clean energy. There's a huge amount of wind energy, for example. In Finland, there's nuclear energy, there's hydropower in Norway. So we have an energy coefficient, a half a year from the writing of the book. So the beginning of this year, that was 34 grams of CO2 equivalent per produced kilowatt hour. And then the average German energy coefficient was 11 times more. So again, where you host the systems have a difference. But if you use renewables or carbon, it doesn't really solve the problem, because if you are using energy, then the clean energy, then somebody else is not getting it and will use dirty energy. And then it's currently the world's energy consumption growing faster than the renewables. So it's actually crucial that we all save energy as much as possible. And then let's just take a brief look at how to do it. So the one or the best way actually is to measure, that you measure, and then based on the measurements you make changes, and then you measure again, and if it has decreased, then you're happy, and if it has increased, then you are not happy, and you try to decrease the energy consumption. So if you can measure, if you are in that position, you're working that kind of software that can be measured with without the biases and so forth, then do it, and then if possible share the results. But if you can't measure, you can always use clock. So the University of Beira Interior in Portugal, they found a strong or very strong correlation for all the, I think that 18 program languages that tested between the execution time and the energy consumption. So if your program achieves the things faster, it will use less energy. This sounds like a layman stuff, but now it's that it's scientifically proven that that is the case, and B, there were no correlation whatsoever, for example, RAM uses and energy consumption. So it might have been somewhere else, but it happens to be in the execution time. So if your software is 1 second faster after changes, then it consumes less energy. Very simple. The other way to do it is to reduce waste. This is a concept that I copied from the lean manufacturing, where it's defined as any action that does not add value to the client. And then the lean manufacturing is centered around eliminating waste from the manufacturing process. Same metaphor in green coding is functioning in software that does not add value but consumes energy. There's a number of different kind of ways. I don't go them very deeply here. I use some examples, but these are explained in the book deeper. And I think that these are in some sort of order of importance. So the first one is that if the software is redundant, it should be shut down. If a software is that there's some watchdog that is watching over a system that does not exist anymore, has been shut down, and then every single minute or every second complains about that the system is not running, maybe sending an email to an email address that doesn't exist, and there's a lot of bounces and what's happening there. Shut it down. Using software in wrong task, there might be very, very delicate Excel programs written with the Excel macros and Visual Basic for application that could be replaced with a few hundreds of lines of C or Rust, and that would be way more performant. User errors, this is my favorite. We users, we are very very determined people. But if we try something and then it breaks down, it doesn't work, I don't get the result that I want. I'll try again and I'll try again and I'll try again until I succeed finally, or I'm fed up. In both scenarios, every single failure before the decision to give up or the succeeding on the task is complete waste. And my advice is never ask anything from the user. It's easiest that if the user can't do anything with the software, then they can't make any errors either. Of course, that kind of software that doesn't ask anything from the user is borderline useless. So you need to ask something, but then you need to figure out that what is the easiest way for the user to provide the input. And remember that computers are excellent at memorizing stuff and people are excellent at connecting stuff. So the program should provide the user as much possible things that the software already knows from the user, and then let them select of those if possible. Because every input that you need to input something is the potential of user error, and then especially if you have done the system with bad UX, then that might actually be the biggest cause in the energy consumption, that kind of wasted energy consumption. The software might have a wrong architecture or wrong data model. It might have too much data that is, or unoptimized data that the data is stored or not transferred in a proper format. There might be the algorithm inefficiency. This is typical coder favorite that yes, we need to have better algorithms, and that sort of goes certain places, but there are bigger ways, easier to fix wastes sometimes on the left-hand side. Deceiving user means that for example, avoiding the contract, getting rid of a service, getting your credit card not to be charged again, might have been made very complex operation, and then you are back in the user error. And then you end up trying a few times, then you read FAQs, then you read the help, you watch a couple of YouTube videos, then you contact the support, and you are just wasting resources, or the system is wasting resources through you. There might be wrong programming language. There are very big difference between languages. If it would be about sustainability, everything would be coded in C or Rust, and nothing with TypeScript or PHP, Python, Perl, Ruby, because they are not that good. But we are not living in a perfect world, and I'm not sure whether I've been coding with C so much that I would not probably prefer a world that everything should be done in C, because it's very low level language at its core. The waste removal is not simple operation, and there are no hard and fast rules how to do it. You need to understand the system very thoroughly, and then you need to spot the waste, and then you need to analyze the impact of the waste and the impact of removing of the waste, how much time and money will be spent that you can actually make it, and what changes the system with waste. And then either you remove the waste or you left it intact, that okay, this is not worth the problem. These two matrices, 2x2 matrices, help estimate that on the y-axis is the impact of the change, that there's a large impact, a good impact, or there's small impact. And then the amount of work might be small and large on the x-axis. So if there's a large impact with small amount of work, you just should do it. If there's a large amount of work that will result very small impact, then don't do it, and everything in between. This is sort of very straightforward, but it helps to select what of these changes are the sort of lowest hanging fruits that should be done first. But then if you think about user experience might become worse, or it might become better, or it might stay the same in the middle of the x-axis. Y-axis is still the impact. So if there's large positive impact that worsens the user experience, then you should ponder carefully. But if the user experience stays the same or it improves, then you should do it now. And then if the impact is small, then you should not do it, except if it improves the user experience, then it might be worthwhile doing as part of the other tasks. and then everything in between. And then the third way to approach this problem is minimization. This is more of a design problem. So the aim is to create a software that does only the major things and nothing else. So it's like a man going to the shop, getting the stuff, going to the counter, paying it out and done. This kind of approach. That nobody's time or anything is wasted. But then again, that might be sort of not good for the shop, that then will lose sales because the people don't linger around and find, okay, I could buy this and I could buy that. Or that the marketing department has a KPI that people should spend time on the website. That okay, if we have like 5 page loads and they are staying there for 5 minutes, then we are in the target. But if they come there and find the information on the first page and then poof, off they go, maybe do some action, then we don't meet the KPIs. But at the end, we might still have customers that are more delighted that spend 5 minutes. For example, in web pages, typical thing people are looking for there is the address of the office. And it's never on the front page, it's never on the top. It's always in the bottom, and typically not it's always on the bottom of the last page in the menu. The thing that people want. And then there might be CEO greetings or fancy pictures of something that is related or not to the company's line of business. And then people come there to look at the office store or contact details or something like that. But this is a balancing exercise that you need to do both with waste and the minimization, that what is valuable, what is not valuable. And the developer should never decide what's valuable. The developer should calculate the impact, but then somebody else needs to tell him or her that what is valuable, because developers are really bad to be running businesses. So if you don't know how to run business, then you should let somebody else to figure out what is valuable. And you can't change everything. We'll come back to that a bit later. So a few practical solutions. In a nutshell, the less execution time is spent, the less energy is consumed. The less data is transferred, the less energy the network uses, and the less hardware is used, the less emissions are caused. So less, 3 things. So if you want to reduce the data, you can make sure that there's proper formats. For example, if you switch to WebP, you will save 10 to 15% of the image sizes compared to PNG and JPEG files without visual degradation of the images. If you know how to cache, then you should cache everything, and you need to have a good caching strategy. If you don't know how to cache, then this is the best way to shoot yourself on both feet. So then get somebody else to understand caching. Especially if you're working with web, WordPress, Drupal, these kind of things, the cache helps a lot. But it might also slow things down a lot if you don't know how to do it. Compress everything that is possible, because decompression is less taxing operation compared to the transfer of the data. And if you can compress it on the build phase or on the software writing phase, then do it there, that you don't compress it on the fly every time. You have a file that is sitting uncompressed on the disk, and then you compress it every time when you send it. That doesn't make any sense. Minimize possibility for errors. We discussed this already earlier. Reduce amount of videos. If you need to have these kind of things, then replace them with animations because they compress better, or static images, or with text. You can't replace every video. There's, for example, in bug reports, a video, a screen capture of that. I did this, and then now I got this error. Might be very beneficial for the developer to understand what's happening and how to reproduce the error. But then looking the 16th or 17th cat video or some other things, or watching TikTok for 2 hours a day might not add any value. And remember with TikTok that it's forbidden in China, so it's one of the best weapons I think that China has developed against USA, that they work the teenagers' brains. Reduce data transfer frequency. So if your system pings back, then figure out that how long times it can sustain without pinging back, every second, every 5 seconds, every minute, every hour, depending on the use case. But if you can reduce it, then you cut the data transfer, and it might be cut drastically. Reduce amount of code. If you have dead code in the system, just get rid of it. Use version control. If you don't use version control, start immediately. Use version control is your friend. When you add new libraries, be mindful. Check their footprint. There is a study made by Lappeenranta University of Technology here in Finland that about 5% of the footprint of the library is used, and everything else is not used by the software. And then if library depends on library, that depends on library, there is a huge stack of code that you might use only some of it. But don't write your own algorithms, don't write especially your own cryptographics. You will fail. So use those, but try to find the minimal versions of the libraries. Limit the amount of code that is sent over the network. This is especially a web-related problem that does every web page need to have a React, or would it be that it actually works with plain HTML better? Because you then need to transfer the React libraries and components over. And then code efficiency. Find the hotspots of the software and focus on optimizing those. Don't spread the optimization all over the place. Okay, I'll do everything in what I can, or do local or pre-metro optimization that I'll focus on that my for loops are running on the right direction. It doesn't really matter. Focus on the big picture, that your system by accident reads the like 10 times or 1,000 times the same database query, because it's inside the loop and not outside of the loop. Find these things. Learn how to optimize software. Everything that is thought in the universities and polytechnics and whatnot about the optimization is valid for the energy consumption, because if the software is faster, then it consumes less energy. Use right algorithms for the task, especially when the amount of data is large. It might be that that if you have a test set of 100 or 1,000 something, it doesn't really matter what algorithm you use. But if there's like 1 billion database rows, then it does matter. Trust me, I've been doing MySQL clustering back in the days, and you learn pretty quickly that sometimes the databases, if they are not designed properly, then they will take ages. And then if you're using slow language, then maybe the critical parts could be written with different language. If that's possible, if that makes sense, if the bridge between two languages does not sort of eat away the benefits, and then you know the other language. This is also a good reason why you should learn a number of different languages, that you would have perspective and you would always be able to select the best tool for the gig. And then final words. This is a journey, so do not expect that all changes can be done at once. There's always a client, internal or external, unless you're doing the software for yourself only, but then the impact is very small. And then the satisfied clients, they allow us to make more changes compared to dissatisfied clients. If you go to this and say, hey, Mr. Client, hey, Mr. Satisfied Client, we have these kind of ideas to make the changes on the system. How about those? Then yeah, he says, okay, very good, let's discuss, and then agree that okay, we have budget for these. But then if you go to Mrs. Unsatisfied Client, and say that, hey, we have these kind of ideas, she will say, okay, that's fine and dandy, but I have this huge list of issues that you need to fix, and the software is not released yet, and blah, 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 blah. And then you end up that all this US engine, that every idea that you have proposed is shut down because the client needs to focus on the business first. And the very crucial thing is that don't set too ambitious goals. Do not try to gobble everything up at once. Eating an elephant is not one single bite. It needs to be done piecemeal fashion, otherwise you will choke. And remember to keep good care of yourself. But if you get burned down from the writing the code, the green code, trying to optimize, so forth, or you have a big anxiety for the environment, and you can't work, then you will be replaced by some idiot that doesn't matter, that doesn't care about these matters, and then the world is worse place. So if you are interested in these things, keep yourself in shape. And then the last piece of advice that what I have is that any journey starts with the first step, and that is the most crucial thing starting a journey, that you take the first step. And I have really, really good news for you all. By listening to me, by watching this show, you have already taken the first step, and now I'll just ask you to keep on walking, because you are already on the journey for the better planet, and we just need to put steps after each one. Thanks. Any questions or comments?
Yeah, thank you for such meaningful and inspiring presentation. And yes, we have questions in the live chat. The first one from Julia. What role do you see for AI in advancing green coding practices?
AI does not play currently any role with the green code itself. So the green code is pretty new thing. The AIs don't that much provide they can't help you code green. Of course, if you are a junior developer, the AI might provide you better solutions for the problems. But as a junior, you won't know that whether this is better or not. That is the problem, that it takes time for you to learn that what's good and what's not so good in algorithms, for example. So it might help in the future. It might that there might be some echo mode in the co-pilot. Okay, let's do this as efficient as possible. This is not the case right now. AI itself is huge sink of electricity. There is estimation that 10 to 15% of Google's energy consumption, that by the way grows every month, goes to the AI, and it's terawatts in a year. So it's huge amount of electricity that goes to the AI for a single company. There was an estimate that one ChatGPT query takes something between 1.7 to 2.6 watt hours. So it means that if there are 10 million users or 10 million queries every day, then it's 17 to 26 megawatts an hour. That is not a small number anymore. So the AI might help, but it won't change the overall picture. But the attitudes of the people are the key. AI might be a good tool. I'm a bit doubting it, but I'm also of an older generation. At my age, I'm almost 50. You start to need to be doubting all stuff, because you have learned the hard way that the stuff just doesn't work as promised back in the days.
Thanks. We had also one question from our registration form. Is it true that using ChatGPT during 20 minutes is as harmful as cutting down a tree?
That is an interesting question. So As said, the amount of energy ChatGPT uses for single query is not that much, but that's only serving the query. The ChatGPT, how much training material it has, the composition of the training material, the gathering of the training material, everything has consumed a lot of energy. And today there was a news that the Microsoft is having a GPU, the graphical processing shortage, and they are leasing the GPUs from Oracle. These companies used to be sort of adversaries back in the days. So the use of AI causes a lot of energy use, and it causes a lot of new systems to be built. Whether that is harmful as cutting down a tree, that is a sort of quasi or semi-philosophical question that I don't really know that what is the effect of cutting down a tree. But there was one person saying quite recently that if the society values the cut down tree more than a growing tree, the tree will be always cut. So it's about the values, and it's about the valuation of things, that what people see more valuable, whether it's use of AI or whether it's sort of handwritten code or handwritten stuff, and so forth. But these are not sort of comparable. Using AI does not cut trees anywhere, but and if you are concerned about that, then just plant new trees. That is probably the easiest way to handle this problem.
Okay, thanks. More questions from Nikita. Are there any certifications or standards that companies can aim for to validate their commitment to green coding and sustainability?
No. There might be in the future. There are now certain things that are going in that direction. First of all, there is a IT energy label called Blauer Angel in Germany. That means Blue Angel. It has the basic is that they have a certain kind of prototype environment that you should calculate at how many of those prototype environments or archetype environments your system uses, and what is the performance there, and whether it goes. The consumption of energy is low compared to the performance, then you might get the label. I don't know any software that has the label. It might be because of me, or it might be because of the complexity of the label. I don't really know. I haven't studied that well, but it's pretty complex way to do it. There are different kind of system. For example, in Google and Azure, they have a pretty good carbon emission calculations that are sort of on the ballpark. The Amazon is not yet there. They might be there, but they have been slower in these matters compared to Google and Microsoft. The problem there is that you don't really know whether your system is good or not. You just know that it consumes this amount of energy, or they don't tell you that how much energy it consumes, but they tell you that how much emissions it causes. But whether it's good, you don't have the perspective or the horizon, and that is probably coming. And then the last thing that might actually change this, is the CSRD directive from the European Union that now comes into place for bigger companies in beginning of 24, that you need to calculate your carbon footprint using the all scopes 1, 2, and 3, where the IT services go to the scope 3. And then it ends that the big companies start to ask this ugly question of how much this does cause emissions. And then they might find out that actually that system causes way bigger emissions than the other. So these people don't know, and we need to use some euro money-based estimates that are typically way off the roof, that they produce way bigger footprint that is actual. So these kind of drivers might change the business so that actually people start to pay attention to these. But there is no simple tool, there is no simple place to go, or if it's simple, then typically it will calculate wrong, or it will misguide you, that it will calculate some parts properly and then estimate the rest. So you need to always now understand the methodology, and I can assure you that this is very, very long rabbit hole, that if you start going there, then it will take a lot of steps before you end in the other end of it, and see if you sort of understand everything. So right now it's more that you should try to write better software and measure your changes compared to previous version. That is the easiest way. And I do hope that this situation would change, but it will change slow. I'm impatient person, unfortunately.
Yeah, I'm sure it will take some time to change our approach and to get there. The next question from Lex: how does green coding relate to accessibility? Both are sustainable practices, but I wonder, how do they work together, if there is any connection?
What was the green code compared to?
To accessibility.
Accessibility, yes. Both are good things. They, in practice, don't have that much common, because the green code is about the performance and accessibility is sort of about the understandability and ability to use if you have certain restrictions. But accessible systems are typically less error prone. So it goes with that if you have accessible system, accessible UX, then the users will do less errors. It might be that the accessible user experience is somewhat more energy consuming to create, because you need to have area tags, you need to have all kind of instructions that you need to test with different tools. But then again, it will reduce errors. And then if you add to the accessibility that it's not just about whether everything is sort of visually distinct and there's the audio possibilities and so forth, but also to the content itself and the user experience itself, but whether this is easy to use or whether this is not easy to use, then you will reduce the user errors, which is a big sink of energy in our world, because there's so many software that frustrates people, and you probably all can, probably even today, have had some issues with banging your head at least a little against the software, and then the software is creating waste because you're trying to do something that doesn't succeed. And the accessibility is a good tool to help in that. And of course, both are good for the society as large, so they both are positive things to do, and I strongly suggest you to pay attention to accessibility
too. The question from Helga: can you recommend any courses on green coding?
There is not really good amount of courses. This is best that I found. I didn't find that many. So there's actually, I'm going to Berlin in a couple of weeks. There's a green code seminar there in 2 weeks. That would be the 23rd, maybe Thursday, 23rd, probably. That then I'll learn more, but there is not that much. There's O'Reilly is going to publish a book about the green software. It's currently available before edits, so it's raw version of the book, but it's available. I haven't not yet read it. It's on my laundry list. My book also is a good primer. I guess that my book is shorter and goes on the sort of more on the bigger picture, and then the green software will go deeper on the architecture and the others. And they most probably will. I do hope that they will sort of be better together than as separate things. But for courses, not really. The problem there is that there is not that much demand, unfortunately. I'm going to most probably have a course in Finland, in Ostrobotnia region, but it's still unsure. It should be like a 1 month from now, that it's still unsure whether there's enough people that have enrolled that it's viable to do it on the sort of financial sense. So there will be more of these in the future, but right now it's unfortunately not that big amount. This is one of the reasons why we are talking right now here. That we at least give a primer of it, that this is scratching the surface, but it's better than nothing. That is sort of the other option.
Okay, thanks. Anna is asking if there are any calculations how much less does the green code harm the environment than the usual one, and how higher are the costs for creation and maintenance of green code?
That is an excellent question, and I always say all the questions that I don't have good answers, excellent questions. So this is something that I should find out myself too. There's a Finnish company that is doing analysis of and then rectification or corrections to the cloud services, sort of optimizing the use of cloud and making changes to the software, sort of both of those, and they get to like 25 to 50% changes in the cloud pricing. That is most probably around the same amount of savings in the energy usage. Then, of course, if you can reduce the amount of servers using there will be even bigger cuts. The amount of coolants used in the data centers and so forth. So it accumulates, it multiplies. How much more does it cost? I'm an optimistic person. I would say that maybe 10%, because you should. It's about the attitude, about understanding when to use the sort of the green code paradigm or optimized software paradigm and when not. If you go sort of all in everything that I'll do as efficient software as possible, then my own experience that I have done with, for example, writing electricity price diagram for Magic Mirror, very simple system, but still it took probably 4 times longer for me to write the code efficiently instead of that I would have write it as any software that used to be done. So there's variation, but the sad fact right now with the cost of cloud is that typically you won't save money-wise that much money that you put in green. So you need to have other reasons to do the green than just the financial things. And then, of course, if you would like to work with green, then you need to find the clients that value the environment more than their own bank accounts. Or they at least balance that.
We have just one question left, and that's fine because we're running out of time. How the design of websites can be more sustainable? I've heard that the black mode uses less energy than the light one. Maybe something else you can advise.
Yeah, the light mode, black mode, or dark mode saves energy if the mobile, only for the currently mobile screens, because that's where the OLED screens are used. So, and half of the mobile devices use OLED. So an OLED uses less energy when it's black. So half of the mobile users will get benefits. Everybody else, it doesn't really matter for the black screen or the dark screens. For the rest, the image changes, reduction of CSS, reduction of extra JavaScript, reduction of third-party scripts, reduction of ads. All these matter a lot. There's a study made by the Seine Lappeenranta University of Technology, about the ad usage that they estimate that it takes around 10% of the internet's energy usage is because of the ad networks. So if you can get the money somewhere else than the ads, all the better, really good, but that might not be always the case. Then I would not focus on the sort of one certain things. Of course, having the dark that it's dark. Most of the website is dark is better than light from the energy consumption. It's very easy thing to do in the beginning of the project, and later changing it might not be that easy. But then other than that, it's not about sort of individual small things, but more about the approach, how you can cut stuff that nobody needs. Videos is a good example. That instead of throwing people to YouTube, have a text about it. I'm also the generation that would actually read the instructions that I have a problem with. Let's say my MacBook's escape key that is in the funky light strip that is on top of the display, and it's not working properly. When I try to fix it, I get to see a number of different YouTube videos, and the solution for the problem is like 5 lines of text that I would rather read. So the world is going in the wrong direction in that sense. So we should start valuing sort of more basic things. I just noticed today that there's now a memory consumption meter on the Chrome tabs, and then the memory consumption of a front page of the biggest Finnish newspaper on the web is 500 megabytes. I don't know where the memory is going. So it boggles my mind that there's like half a gigabyte of memory used to see like 20 articles, 30 articles on the front page. It makes no sense whatsoever. I sort of understand that this presentation that I have here is like 200 megabytes, but half a gigabyte for a website for a newspaper. There is probably a lot of stuff that is not actually needed. If there would be like a tax, or the electricity would be way more expensive. And now I also understand why it breaks my old iPad that I can't use the site anymore, because it just takes too much memory. But I'm not working for them, unfortunately, so I would try to fix it if I would be working for them.
Thanks. You just like made me ashamed because I have 100,000 tabs open in my Google Chrome, but I will close them immediately. Thank you for this presentation, for making us more responsible and more sustainable. And I want to express my gratitude to all listeners who stayed till the end with us. Highly recommend you to read the book, Green Code, and to follow Janne via LinkedIn or other social media. I don't know. I guess you will find more useful information there. Tomorrow we will send the link and the presentation to you, so you can refresh it in your memory wherever you want. Thank you, Janne, and I wish you
and it was a true pleasure.
Yeah, same here. Wish you a nice evening.
Likewise. Bye for now.
Bye.